So last unit, when we were learning stoichiometry, do you remember we talked about at STP, or standard temperature and pressure, 1 mole of gas always takes up 22.4 liters. Do you remember that conversion? Okay. And so that's a nice way to be able to convert from moles to liters. However, you have to be at 0 degrees Celsius in 1 atmosphere. So today we're going to talk about, well, what happens if conditions aren't at 0 degrees Celsius or 1 atmosphere? How do we figure out the number of moles of a gas then? So then the equation we use to figure out number of moles, if we're not at STP, is we use something called the ideal gas law. And so go ahead and get the equation down in your notes. So the equation for the ideal gas law is PV equals nRT. And then this time, units are very specific. Okay, so the P in that equation stands for pressure, and pressure has to be in atmospheres. Okay. So if you need to write down, especially the units you need to use, go ahead and write those down. V stands for volume. This time, volume has to be in liters. N stands for the number of moles of a gas. R is just this gas constant, and it has the same value all the time. However, you do need to write this value down. So R is 0.0821. And its unit is a liter times an atmosphere divided by a mole times a Kelvin. And then T still is temperature and has to still be in kelvins. Okay. And so then the reason why units matter so much for this equation is all back to this R value. Okay, so since R has the unit of liters times atmospheres divided by moles and kelvins, all of your other units have to match that. All right, so then we're just going to do a couple practice problems together. Okay. We'll practice solving for different variables. Okay. So our first one is, at what temperature will 0.0470 moles of gas fill a 1.20 liter balloon at 0.988 atmospheres pressure? Okay, so same beginning as always, so we're just going to write down all the numbers given to us. Okay, so what's the first number you see? Okay, thank you. So 0.0470 moles. And if you look at the previous slide, what letter do we use to represent moles? Okay, think N as a number. Okay. So N is 0.0470. Okay, what's the next number you see? Okay, 1.20 liters, and what's a liter? Okay, volume, so V is 1.20 liters. What's the next number you see? 0.988. Perfect, and the unit for that is? Pressure. Good, pressure. So pressure is 0.988 atmospheres. All right, and then what are we solving for? Okay, we're solving for temperature. Someone put a question mark for temperature. Okay, so now what gas law do we know that doesn't have initials or finals, but it's also including number of moles now? The ideal, right? So we know we're going to use PV equals nRT. Okay. Is R ever going to be given to you in a word problem? No. So just R, you wrote down that value. We'll probably end up memorizing that value because we're going to use it a bunch. But just know it's never going to be given to you in the word problem since it's just a constant number. Okay. You may plug your numbers in now and then solve for it. For an ideal gas law, I like to rearrange my equation first and then plug my numbers in second. Okay. So we're solving for T. So how do we get T by itself? What do you do with NR? Not subtract. Not add. divide. Right? So they're multiplied here. So we're going to divide both sides. So we're going to divide both sides by NR. Okay. So T equals PV over NR. So now that I know like the order of my equation, now I'm just going to plug in my numbers. Okay. So P is 0.988 atmospheres. V is 1.20 liters. Okay. N is 0.0470 moles. And then R is that constant. Okay. So it's the 0.0821 liters times atmospheres divided by moles times Kelvin. Whew. Okay, next step is just to calculate. I'm just going to add parentheses. If I were you, including the parentheses, I would enter it all one time in my calculator. Okay, so put like parentheses around your top row, divide, and then put parentheses around your bottom row and divide. And you should be able to put all of this in your calculator like all at one time. Okay, so you shouldn't have to chunk it out. Okay, so practice typing this in your calculator. Can you enter it where you're getting the correct answer? Okay, so we're getting 307. What's our unit for temperature? Okay, Kelvin, we might just already know that temp's always in Kelvin. You can also look at your units and they should all cancel except the unit of your answer. So we have atmospheres divided by atmospheres, right? Those would cancel. Liters divided by liters will cancel. Okay, we have moles divided by moles will cancel. And again, so in case you're not sure your unit, so you say your only unit that didn't cancel is Kelvin. So that's also how you know your unit. Okay, so our second one, how many moles of oxygen will occupy a volume of 2.5 liters at 1.2 atmospheres and 25 degrees Celsius? Okay. So you start by just listing all your variables. Okay, what's the first variable you listed? Okay, 2.5, and what is that? Okay, so V is 2.5 liters. What's the next variable you listed? Okay, and what letter is that? Okay, so P is 1.2 atmospheres. What's the next one you listed?
25 degrees Celsius.
All right, so T is 25 degrees Celsius. Can you be in degrees Celsius? Okay, so what do you have to do with that number? Okay, so plus 273. So how many Kelvin is that?
298.
298. Okay. And then what are you solving for? Okay, number of moles. So what letter do you give that? Okay, make sure you go N. I know it's tempting to say M for mole, but it's N for number. And the reason why N is because now that you see N, that should be a little clue as to what equation you use. Okay. So again, what equation are we using? What's the name of the equation we learned today? Okay, good. So we're going to use the ideal gas law. So PV equals nRT. And then this time we're solving for N. So again, you can plug in your numbers first and then solve. I personally just like to rearrange my equation first. Okay. So how do we get N by itself? Okay, we're going to divide both sides by RT. So N is going to equal PV all over RT. So now can we just plug in our numbers? Okay. So I'm just going to write them exactly in that same order. So 1.2 atmospheres times 2.5 liters divided by R, which is 0.0821. And then T is 298 Kelvin. And then when you're ready, go ahead and practice putting that in your calculator. Okay. Again, I would add just an extra set of parentheses in my numerator and denominator and just do it all in one shot. Okay. So practice, make sure you know how to use your calculator. Can you get that correct answer? Okay, we're getting 0.1226. And what's our unit? Moles. Good. Okay, this one. What volume will 2 moles of nitrogen occupy at 720 torrs in 20 degrees Celsius? I'm going to help you get set up, and then I might have you do the second half on your own. Okay, for this one, what's the first number you see? 2. 2 what? Moles. So what number, or not what number, what letter do we use to represent moles? Okay, so N is 2.0. Okay. What's the next number you see? Okay, 720 torr. Any guesses what torr represents?
Pressure.
Good, pressure. So P is 720 torr. And then what's the next number you see? Okay, 20 degrees Celsius. And what letter does that one get? T. Okay. Can we ever be in degrees Celsius? Okay, so what are you immediately going to do to that? We're going to add 273. So how many Kelvin is that? Okay, and then what are we solving for? Volume. Okay, so what equation do you know that has N, P, T, and V in it? Okay, ideal. So we're going to use PV equals nRT. So now that we know we're using the ideal gas law, do these units matter? Okay. Okay, so which one up here has a unit that we have to convert? Pressure. Okay. So we can't be in torrs, we have to be in atmospheres. Okay. All we have to do is just divide it by 760. And then if someone has a number, can you say it out loud?
0.95.
Thank you. Okay, so it's really 0.95 atmospheres. Okay, so now I want you to try, from this point on, see if you can solve for volume without my help. Okay, so if we rearrange for volume, we get nRT over P. Okay. Do you agree with how it's set up? Okay. Anyone have a number for volume yet? What do you have?
50.6.
Okay. Do y'all agree?
Yeah.
Okay, got a second one. Anyone else have 50.6? Okay, I see a couple nods. What's your unit? Okay, liters. Perfect.